for now. Welcome to day 2 of LayerOne. Everybody get breakfast? Good, good. Was it good? Good. Good, good, good. Some announcements for today. Everybody got their badge and got their badges flashed. If you did not get your badge flashed, so if you have a white or a purple screen, just take it to Hardware Hacking and they'll flash it. It takes 5 seconds, and then you'll get all the logos and all that on your badge. They're also selling kits if you want to get the NES controller, SD card, if you want to get a programmer or a CAN bus cable. Read all about your badge and your program. Aside from that, CTF is still going on today. The Camper Evident contest is still going on today. At 11 o'clock, right after this talk, the HeboCon robot battle begins in the Hardware Hacking Village. At noon, there's Intro to Lockpicking in Lockpicking Village. And I believe that's all the contests for today. Oh, excuse me, Fail of Things at 3 o'clock in the Chill Out Room. Other than that, I think you guys hopefully know the drill by now, so have fun, do things, meet people. Up next, we have William Turner getting off the grid and onto Hyperboria. Please give him a small round of applause.
Hi everyone, I'm William, and I'm going to tell you a little bit about a cool network some people are working on building out that's kind of similar to the existing internet, but in many ways highly different. So let's get started. So some of the things I want to talk about: what is a mesh network, what are some existing mesh network technologies, and what is Hyperboria, how to connect, how to use it, and yeah, we'll just start with what is a mesh network. And so this is kind of the pedantic textbook definition in which you require a mesh network to be, with all nodes to be connected to each other, and you can route through any of those other nodes. I think in practice, when we make these things, it doesn't actually work out that way. It would be nice if it does, but it doesn't always. Some of the differences with certain types of network architectures that we see more frequently: centralized, don't see that as much anymore. Decentralized is kind of, becoming the current norm. But this distributed pattern is really what Hyperboria is shooting for, basically to facilitate the routing protocol. And so when you think of a mesh network, don't think about like 802.11s or anything with 802.11 or even TCP/IP, because that really kind of limits the scope of the power, the things you can accomplish with these types of networks. Really, you should think about solving connectivity problems, connecting machines, and connecting people. So there's actually a lot of mesh technology that exists. It's existed for decades. It's nothing new. One of the more popular ones is called BATMAN, which is an acronym for Better Approach to Mobile Ad Hoc Networking. That one operates at layer 3. There is BATMAN Advanced, which operates at layer 2. And there's a kernel module you can download and install. There's OLSR. There's a group actually in Southern California that's operating a network called the Arden network. And what they've done is they've taken 802.11 and frequency shifted down to 400 megahertz to be in ham bands, and then use OLSR to build a network that extends roughly from Santa Barbara into Orange County. And so the purpose of that was to be like an out-of-band emergency communication channel, basically for disaster relief efforts. You have IEEE's 802.11s, and you have CJDNS, which is the one that I'm interested in talking about today. You also have Zigbee. So if you've been to the hospital and had like an electronic bracelet on that's monitoring your heartbeat, those typically form a mesh network with other devices in the hospital to route traffic back to main controller nodes where the data can then be input into some sort of database tracking system. You also have Z-Wave, which is used for home automation. It's kind of a more interesting one too, because it will communicate through the wires in the wall or through radios as necessary, but forms a full mesh between all of them. So this might be a little bit basic, but some of the stuff we need in order to actually build out a successful mesh network is we're going to need some layer 2 connectivity. And so this just kind of shows you could use BATMAN Advanced to get that, and you can communicate. And for more functionality, we probably want like a layer 3. And so that's more what this talk is about. So let's talk a little bit about Hyperboria. Hyperboria is a wide area network that uses CJDNS as a layer 3. Currently, there are around 1,500 nodes. It's very hard to track because these are not nodes that are set up in a data center with HA stuff. It's more like some guy with a Raspberry Pi turned it on and then maybe unplugged it. And so it's kind of a challenge for the community to actually track the growth. Initially, the project relied on trusted peering with neighbors to gain access to the network. And so what that would look like is, you go meet your friend, you do a key exchange, and then you're able to connect to each other and peer. That kind of fell out of fashion in recent times, somewhat unfortunately, just because of the challenge in finding peers. So there is an auto-peering discovery mode that is available right now within the software. And there are also some sites, it's like a GitHub repo that you can use to find existing peers and share your peering information if you wish to be a public peer. Hyperboria has some of its own services, which we'll talk about a little bit later. There's some storage services. At one point, there was an email service. I think it's now defunct. There's IRC channels, websites, things like that. And these are all only reachable if you're actually on this mesh network. It contains bridges to the existing internet in the form of VPN tunnels. And so you can make and operate a node that does that. And it was formerly known as Project MeshNet. And so one thing that's kind of interesting about CJDNS is instead of just using an arbitrary IP address, you take a portion of your public key and actually create a mapping from that to an IPv6 address so that the identity is inherently coupled with the address of the node. So this is a map of Hyperboria we can kind of take a quick look at. And so this shows 675 nodes up and shows some of the links going between them. If you're very observant, you might notice that there's a lot of Canadian URLs here. The principal developer and benevolent dictator for life of CJDNS is a Canadian, and so a lot of work has been done in Canada as a consequence for that. And so right here, we're seeing peers connected to Transition Tech, to their public peering endpoint. And so you can see there's some IPFS gateways, some websites, links back to a sub portion of the mesh network in Philadelphia here. So this actually serves as a pretty decent tool for trying to find public peers. Nothing is really guaranteed. There is a password that's used to protect peering that you'll need to have. But this is kind of a good resource to actually view the progress of the network as a whole. So how do we connect to Hyperboria? So first thing you need to do is actually build CJDNS, which is not that hard. But once you do that, you create this configuration file called a cjdroute.conf. And so CJDNS binaries will automatically generate this config file with your public key and private key, leaving you and a default password, basically. And then you can change all of this to secure it. So once you have that, that's pretty much all you need to actually start the daemon and start running it, but you really need a peer. So if you go to this GitHub repo, and I'll share this talk out later, there is a list of peers. I will caution you that it will be incredibly frustrating because probably half of them are going to be defunct and not connect. And I'm sure if someone wants to submit some PRs to that repo and clean it up, it would probably be quite welcome. So once you have it compiled and built, you can go ahead and consume the config file that you just made. And it'll start up. So looking at this, we're using a UDP interface for this instead of using Ethernet frames. There's a few different modes you can operate the software in. And then it creates a tunnel type device node to bridge it with the existing internet. So this is the VPN bridge style setup. So you will need to have root access on your machine in order to run this software. But I think considering we're modifying network parameters, it's kind of a given. Let's see. So immediately once you start it up, it
in the current default mode, it starts to try and do auto peering. And so it starts mass scanning for nodes that are within the network. But still, if you don't have any peers, this isn't really going to do too much for you. You really need to find at least one peer at first. And that's where going to that repository can be pretty helpful. So looking at this, you'll notice that all of these IPv6 addresses start with the prefix of FC. This is a private range within IPv6, so there should be no conflicts with this on the internet unless someone is doing bogus BGP announcements for these routes, which should not happen ever. So it's safe to run with existing hardware. It's safe to run the existing internet without risk of causing any real bad damage. So once you're connected, let's see if I can go to the next slide. There we go. You're going to need some tooling. You could do a ping 6 to some of the nodes, but you're not going to be able to list your peers that way. And unless you want to just use curl with a REST API and commands like that, one of the tools you might want to get is a tool called CJDCMD NG. It is a Golang project. And if you follow the instructions here and you have Go installed, you should be able to get a working binary. I made this demonstration using ASCII casts, so these are actually all selectable text. And so when I publish it out, you can probably follow along with this and get the commands that way. So we've got our binary now. And let's kind of take a look at some of the options. So a lot of these are very specific to CJDNS, but a lot of them will look familiar. So we've got stuff for managing our config, stripping comments, showing the unique public key, fingerprint, listing peers, assigning a nickname for a host for the IRC system that's run there. But then you have some more things that kind of look familiar, like a ping, trace route, being able to check routes to a particular node within the network, and then viewing traffic statistics. So those all work pretty much like how you would expect them to work. So we can take a look at what that looks like. In order to use the tool, when you start CJDNS up, it has it's listening to actually take network traffic, but it also has an out-of-band management interface that's used to do some of the administrative features for it. And so to use the tool that I'm showing, you need a file called .cjdnsadmin in your home folder. Just create a dot file and tell it what address you're connecting to, tell it what port you're connecting to, and a password that's stored in the cjdroute.com and where that file is. So once you get that, you'll be able to do nice things like ping or do a trace route. And so we can see what this looks like. For the sake of simplicity, I use the IPv6 address, but you should be able to use this as an address as well, which is the public key representation of the mapping to that IPv6 address. And so we can ping a node. So that all looks fairly similar, except the interesting thing is the only nodes that your node actually knows about are its neighbors. And so by the time it routes traffic to one of its neighbors, that node then decides what the next hop is. And so that's kind of what largely makes it different than kind of how we're used to visualizing network routes in certain ways. But in certain ways, it's totally similar. It's just kind of at a different scale. And so we can list our peers as well. And so for this demo, I had one peer. Somewhat sad, but some parts of the network were unreachable just via this peer. That's because it's not a full mesh network. It's not perfect. It was made by humans, and you know, as such, will have some issues. So what kind of content is on this network? Right now, the answer is there's not probably that much good content on the network, but there's some potential, and it's starting to grow. So one of the cooler, more interesting technologies I've seen deployed there that does seem to be active and have a bit of content is IPFS. I don't know if anyone here is familiar with IPFS, but it's the Interplanetary File System, and it's a type of content addressable network. And so the difference, you know, like currently, if you want to view an image or a video, you say exactly where that image is, and you go directly to the source. Well, with a content addressable network, the idea is that the address is a unique identifier for the content, and based on routing protocols, you figure out where it makes sense to get that content from. So it sort of captures the notion of a CDN, except behind the scenes at a protocol level. There are some software mirrors on there. And of course, there's websites. You'll find people's blogs, photos, things like that. You'll also find, you know, typical things you would find on certain dark nets. I personally don't really think that Hyperboria is a dark net more than it is a project, an experiment in actually trying to build a large-scale mesh network. I don't think it has the same ethos as certain other projects that we see. But you know, regardless, it can get interesting. But what's missing? And also, kind of sadly, the answer is a lot. There's a ton missing on this network that makes it not feel like any sort of network we're used to using in a modern age. So a few important ones might be DNS, unless you like memorizing IPv6 addresses, publishable storage, and out-of-band node management. And there's not really any governance model. Like, what happens if one of the nodes is causing some sort of traffic flooding to another node, things like that. There's also no way to do distributed caching right now, meaning, like, let's say you've got some amazing video that you're hosting on one of your nodes, and 100 other nodes in the network want it. Well, there's no like squid-like caching proxy or any sort of layer like that that would know to automatically start caching that content on nodes closer to the source that actually wants it, you know, in a hot kind of way. So there's not really any CDN-like structure at this point, but that's something that IPFS could change. So with respect to DNS, there's actually quite a few solutions, and it's not actually a problem that hasn't been solved. It's a problem that hasn't been implemented due to politics amongst developers. So Namecoin has been around for many years right now as a way to do decentralized infrastructure, decentralized DNS backed by blockchain. That project hasn't seemed to have gone too far as of late. There are some restrictions in the length of the names that you can use that I think have been a little bit prohibitive. There's DNS Chain, which supports more top-level domains than Namecoin. It's a pretty similar idea. One thing that's kind of unique about it is it actually supports multiple blockchains as a backend. One of the more promising ones, and it's a little bit newer, is called Emmercoin. And it's kind of cool because it doesn't actually just do DNS. You can actually use it to do blockchain-based SSH key management or even SSL certificate provisioning. And what's cool is when you run the daemon for the wallet that basically manages the collection of the tokens and the tokens you would spend to register a DNS, you know, record or things like that, that's actually its own fully RFC 1034 compliant DNS server in and of itself that you can use. So that's nice. You kind of get this really redundant infrastructure connecting into this decentralized fabric where you can get things like DNS. Now, none of this stuff has really been implemented in any sort of scale on Hyperboria yet. So what it kind of looks like is some guy will have been like, oh yeah, I'm going to use Namecoin. I'm going to start, you know, adding records and doing this thing. And someone else says, well, no, I think that's a garbage project. Like, I have this system that I use where I check this file into Git and I manage host records on all of my nodes. And Then you'll have people who are trying to push the bleeding edge. You have people who have written their own DNS systems completely from scratch, but then they host it in a centralized manner. But that's okay, because they only care about their nodes using it. And so that's kind of like the current state of affairs with respect to DNS in this network. And so I was chatting with one of the developers recently, and because of all of the politics, what he's basically looking to do and build into the CJDNS binary is like an abstraction layer that would facilitate using different DNS backends. And that way he can kind of abstract himself out of that argument and let the rest of the community, you know, through via kind of like a grassroots process, actually figure out like the hell DNS system should we use. So yeah, decentralize and distribute storage is also kind of a problem. Things just won't really work well unless you can bring the storage close to where people actually need the files to be. And so this kind of goes back to my comment about how there's no caching layer by default right now. And that's a problem that could really stand to be worked on. Should have been something loading there. Yeah, so IPFS is a protocol I mentioned a little bit earlier. It's a content addressable network. And basically, when requesting a file, each file has a unique hash that's represented on the network. And on the back end, based on proximity, it will figure out where to grab the file for you. What the problem with this, though, is why would I want to offer my storage up? What do I gain? I mean, I've got to pay electricity for this. I'm inherently taking risk about people putting content on there that could get me in trouble. And, you know, it doesn't really, the technology is cool, but it doesn't really solve the problem or any kind of issues that we would encounter. So recently, there's been development there to create something called Filecoin, which is a tokenization way to incentivize people to actually provide storage on IPFS. That has not happened yet. They're doing an ICO pretty soon and are probably like a year plus out from that actually being a reality. But it's starting to look more and more promising. Storage is another blockchain-based platform that allows individuals to sell storage on their machines. It suffers from a few centralization pieces, and one kind of major problem with it in my mind is they only pay the people providing storage on a monthly basis. And it runs through this kind of centralized business, for a lack of a better term. I'm not sure if they've incorporated it or not, but it's definitely not as distributed in any way, shape, or form as IPFS. But it does have the incentivization. And so one more that I've been looking into that I personally am starting to believe more in is one called SIA. And what's interesting about it is it's also blockchain-based. It's written in Golang. The code is pretty easy to comprehend, pretty easy to understand. But what's really cool is they actually implement Reed-Solomon encoding by default. And so, you know, for the longest time, lots of storage for the sake of redundancy would be doing, you know, you'd use your RAID arrays. Well, with Reed-Solomon encoding, you mathematically hash out chunks of data and spread them across different disks, and also with enough parity on there, so you have a certain reliability tolerance there. And so with this, your data is actually just chunked out across a bunch of storage on the internet that you're basically unaware of where it's going. And so with storage, they don't have that. It's on their roadmap to implement, but what they do is basically mirror the data. So you say, okay, I want to put the data on node A, and then I'm going to pick node K as my copy, and if I'm paranoid, I can do 3 copies. But I don't really think it's probably reliable enough yet. The word enterprise is floating around, and I think that's a lie. So, you know, in thinking about this network, we got all these problems. It's a cool piece of technology. It's actually pretty performant. But how can we actually move forward with building one of these networks and helping this community and actually making it into something useful that we would want to use? So to build our own one of these networks and connect to Hyperboria, or even our own standalone network that could be different, we would need hardware, we need software tooling. Right now, you know, one issue that really pops into my mind is if I'm operating 10 of these nodes, how do I manage them? How do I do a firmware upgrade on all of them? How do I, adjust IP tables and say, like, I don't want these nodes to be able to connect because they are constantly trying to, like, hack me, things like that. So right now, the only way to really do that is to use that out-of-band interface with the REST API. There's no kind of tooling or node manager or any kind of notion like that. And there's also no governance model in place. There's no way to kind of dictate that you're being, a bad citizen of the network and overall jeopardizing the operation of the network, so we're going to kick you off the network. So that's kind of something that I think we should look to see and investigate making it. But also the community. The community built around this is very, very focused on the pure aspects of the technology. And I think often one thing that's overlooked is the fact that, like, the goal of the project is not to connect a bunch of Raspberry Pis together because it's cool. The goal is to actually, like, connect people together so that they can share content and communicate in a more free manner. And so, here this technology doesn't sound maybe that necessary, but there are cities in Africa that only have their internet because of mesh networks that have been built out over the span of 100+ miles from a city that actually had a realistic, had a carrier-provided internet connection. So the technology really, in my mind, is kind of like this democratization layer for the internet, in almost every regard. So thinking about this, there are some existing groups like the Toronto Mesh Network group. The creator of the CJDNS protocol, I believe, is actively involved in that. They're using a lot of Ubiquity hardware along with custom firmware flashed onto it to go ahead and just run the protocol there. There have been some issues, I think, with certain Ubiquity hardware, and now you've got to buy them from China because of an ambiguous FCC law, but it still works pretty well. But we're also starting one in LA. And so this has been something that I've been kind of passionate about for the last 4 years, but hadn't really done anything. And I just kind of got sick of not doing anything, and I figured, what the hell? See if anyone's actually interested in this. So we call ourselves the Los Angeles Wi-Fi Meetup. The title's a little bit of a misnomer, but I wanted to kind of keep it kind of apolitical and just kind of bland, to say the least. And so we had our first meetup on Thursday, actually, and the goal is to actually build out a decent-sized mesh network in the city of Los Angeles with content, with actual use. Ultimately, we want to get buy-in from city council and things like that to be able to provide emergency communications on it. One, kind of issue that I like to think about a lot is if there's an earthquake, I'm highly confident that you can tune into a radio station and get information about where to go, what shelters are open, things like that. Who knows what that radio station is anymore? And when I ask people who are into technology and even into radio that are my age, and they say, well, yeah, I don't really know, I then imagine about the 13-year-old, the 15-year-old with their iPhone, and they're not going to be able to know where to go. And so that's kind of one of the pitches that we're looking at for getting some involvement from emergency responders for some support of this network and maybe some node installation. So if anyone's interested, I would encourage you to check our meetup out. We're just getting started. It's still early phases. But yeah, that's our goal, is to build out a decently large-scale network in the city of LA. The project, I'm sure, will take more than a year, and we want to do it right and not try and make it a hobby project, but try and make it something that will actually have an impact on people's lives. If you want to reach out to me, here's some of my contact information. Here's the link to the meetup, my Twitter, my email account.
Any outreach going on with the emergency services fire?
So, right
And I remember when we had the station fire a few years ago, it was really disgusting the way there was no information available for about 3 days. And emergency services had for another area.
So right now we haven't started reaching out for sponsorship and funding at the moment. What we decided to do, basically the position that I'm taking with this group is like, I started it, it was somewhat my idea, but there's way too much work to be done for it to even be construed as my project. So we don't have a roadmap yet. I have an idea of the roadmap in my head, but at our next meetup, we're gonna actually try and lay out a long-term roadmap for the goals of the project. And so I think once we have the roadmap and once we get started and feel like we've made a little bit of progress on the vision, then at that point, I think would be the more appropriate time to reach out, just so to add some more legitimacy to the group. Yeah.
Go to the wrong place.
Oh, yeah.
I have kind of a personal peeve.
Sure. Oh, sure. And that's data that you should be able to rely on, too. Does anybody else have any questions? Or? Uh-huh.
So, in the way of democratizing internet networks, can these mesh networks be viewed as an alternative, like projects like Tor or something?
Yes, kind of. I don't think it provides a similar, it doesn't provide a similar style of anonymity to Tor. I think a lot of these other networks are focused more on privacy, whereas this focuses more on security, and I think there's a huge overlap there, but this is definitely not like an anonymous darknet type of network. The focus is more on the ownership of data and the ownership of who you're connecting to and talking to. Yeah.
Can I use the mesh network?
Yeah, and that's part of the idea is you're not, and not even government restrictions, but now that we're facing a non-neutral internet, you know, I'm imagining this kind of dystopia where in order to access Wikipedia, you've got to pay an extra $30 a month because, I mean, hey, why not? It's capitalism and Wikipedia is useful. You can make money off of it. And so with that kind of thinking in mind, we like to say that the internet is like this utility that we use, but and is like, you know, should be a right and things like that. But at the end of the day, when it comes down to you having to pay $60 a month to an ISP to access the internet, it's not as democratic as it might seem. There are a lot of people that can't afford internet connectivity like that, and I don't think it's really fair for people to be marginalized. So, yeah, absolutely, it could totally be used to host content that you feel could be threatened by an ISP presence, I would say. Uh-huh.
Project in New Zealand called the Survival Mesh project, and I guess their platform is just using mobile phones to create a mesh. Is this something similar where you would create either like a use Wi-Fi direct technologies or Bluetooth to connect phones, especially in Los Angeles since we're so crammed in?
You could, and I think it's a fantastic idea. I don't think the protocol has good cell phone compatibility yet. They've been focusing a lot on tuning kind of the underlying ways the protocol works because it gets a little bit complicated. But ultimately, I think that's kind of the best way to go. There's a gentleman who's joined the meetup group who has actually made his own, I think he's a postdoc researcher who's made his own layer 2 switching protocol that they want to implement actually on silicon to do exactly what you're saying. So don't even make it software, but make it hardware, and you could auto-negotiate peering, you know, and then the vision would be like, oh, we're all in this room with our cell phones. Our phones now have formed this communication fabric just automatically at a hardware level. Obviously, that's not going to happen tomorrow. It's not going to happen in a year. The guy estimates it'll probably cost $40 million to implement, but it's something to keep in the back of your head about what could actually change the future and be a cool project. Are they purely software-based, or are they?
To my understanding, I think it is software-based because you do, I think it's mainly on Android that it runs, and you do need root access. It's just an app, and it creates, it starts broadcasting a signal and you connect to whatever's closest to you.
That's cool.
can make free calls on it,
Nice.
send free text messages.
That's way
Again, I first heard of this back in 2012 or so,
Mhm.
and it was barely starting off. I mean, it's really hard to start up those kind of networks.
Oh,
because
totally.
of the infrastructure required and then the money to
Yeah.
get things rolling. But
Absolutely.
I think it's more feasible this way because everyone's carrying a mobile device of some sort, and it's easy to mesh it together
Yeah.
if it's properly implemented.
Yeah, and I totally agree with you. I think the big challenge, though, at the human level there is to gain any sort of scale. The requirement to root the phone becomes an issue. And maybe, oh, yeah. Yeah, exactly. But I mean, that's kind of what I'm liking about this group that we're assembling is we're trying to tackle the real world problems and not just be like, well, it works in my lab, this is cool. We're trying to actually think of the ugly crap, like you mentioned, like battery life. Like, yeah, if it makes your cell phone last half as long, you might not really care about your privacy as much if you're just trying to like go on Twitter or like, I don't know. But yeah. Anybody else have any questions, comments?
You're actually a node on that network, right?
I am, yeah.
How well does that scale the routing?
So it scales quite well. I can't answer in too much detail. There's a white paper you could check out. I could add to the presentation to post online later. But the performance is pretty good. It uses a Kademlia-based distributed hash table for the routing information. But what's nice is since each node only needs to know about its neighbor, your local table doesn't really grow too large. I think there are some like really nitty-gritty underlying protocol aspects that are still being tuned. But from what I understand, the performance in many cases is better than OLSR or HSLS. So it's pretty good. Yeah. Cool. Well, thank you guys.